Am I audible for all of you? Can you confirm it? Okay. So now it is the time to move forward about the continuation process of NumPy. So last session, we had a discussion about which topic we completed. We are in the discussion process of statistical functions. Statistical functions, we are in the discussion. Okay. Statistical functions, we are in the discussion. Median. We had a discussion about median. So what is meant by axis is equal to 0? What is meant by axis is equal to 0? Axis is equal to 0 means what? Columns. What they are called? Columns they are called. Columns. Axis is equal to 1 is called what? Axis is equal to 1 is nothing but rows. So we have seen already this type of discussion in our class. This type of discussion we already had done the examples also. We did the examples also on that area. Okay, guys. Right. Now it is the time to see. To move further. Median. All those things we did. Max, min, etc. we did. Similarly, continuation process of that, we are going to talk about another type of discussion that is called, see the another function here, variance we are going to talk, variance we are going to apply. See that another function called variance. So what is this variance we are going to discuss? Very simple. The formula for variance is equal to, simple. The formula for variance is equal to, actually you need to write the square, not square root, square of any statistical students. Any statistical students are there, you will come to know. Xi minus xi means x1, x2, x3, etc. Xi minus mean by total number of elements. I will give the example also, don't worry. Total number of elements. Right? So look at that. Formula for variance is equal to square of xi. Xi means each element by total number of elements. Let me take up that example. Let me write a syntax also. So I am writing syntax here. Carefully try to look at. So I am going to take something like this. What is it, you know? Variable name is equal to, there is nothing but result is equal to, variable name is equal to numpy dot variance of ndarray object. ndarray object. Okay. Next, this is called syntax number 1. What is the syntax number 2? Similarly, you can apply syntax number 2 also we can apply. What is the syntax number 2? As we have seen that syntax number 1, 2, 3, etc. Here also, variable name is equal to, comma, what I can write it? Axis is equal to 0. Axis is equal to 0 means I told you already. Variance for what? Column wise. So I can say variance for column wise. I can write it. Variance for column wise. This is syntax number 2. Similarly, I will take as it is. Syntax 3 is equal to 1. Variance for row wise. This is called variance for what? Row wise. This is the one. What are the syntaxes? Let us go for the syntax example now. Let us take the Python command prompt Let's move to the Python command prompt. Right now, yes, so there you try to look at. There you try to look at once. Here I am having import numpy. Import numpy. Okay, of course, numpy as np. Alias name I want to take it. A is equal to take one ndarray object np dot array np dot array of. I'm taking the data as 2, 1, some small elements I will take, small elements I will take it, 2, 1, 4, 3, 4, 2, 1, 4, 3, 4, 3, some small elements I will take it, because so that easy calculation you can take it, 3, 5, some small elements. So this is a data I took it here. This is a data I took it. So I'm taking these elements. Okay, right. You print A. This is my data. This is my data. So what is our formula says here? Variance is equal to, first you need to find out the mean. What is this xi here? This is called x1, x2, x3, x4, x5, x6. This is the data. What we have is called data. This is my data. x1, x2, x3, x4, x5, x6. This is my data. Okay. Now I'm writing A is equal to np dot array of 2, 1, 4, 3 and 3, 5. So next I'm going to introduce, I will call it as, first I will find out the mean, because you also need to understand now, because directly if I go for variance, I can calculate res is equal to variance of np dot variance of, I can write directly A, I will get the result. But you should know the calculation part. First I need to calculate the mean. So m is equal to mean m is equal to np dot, for your calculation purpose only I am doing mean of A. Print m. M is printed, 3 is printed. Now what I want to print? Variance I want to print it. Variance is equal to np dot var. Variance is equal np dot var of A. How it is done? Now I'm going to take formula. Let us see the formula once. Variance is equal to square of all these things. Square I need to do it. Square of xi minus mean, like that I need to do it. Xi minus mean, square of that entire elements. Okay, so let us go for square of that entire mean. How do you do that now? Let us go to the example part here. How do you do that mean now? Let us start this example. Can anybody can say? Calculate that. Square of means whole square it will be, whole square. Now what is this now? 3 and then first element. 3 minus 2. 3 minus 2. Whole square plus what is next? 1 minus 3 whole square plus, carefully 4 minus 3 whole square plus, I will take 3 minus 3 whole square, minus this is minus 3 whole square plus, I will write 3 minus 3 again whole square, 3 minus 3 again whole square, plus, I will say 5 minus 3 whole square, by number of elements, it is equal to 6. That is equal to, I can say 3 minus 2 means 2 square. This is called 3 minus 2 means 1. 1 square means 1 plus 1 minus 2 is called minus 2. Square means 4 plus 4 minus 3 means 1 only. 1 plus what next? 3 minus 3 is 0 plus 3 minus 3 is again 0 plus 5 minus 3 is called 2 square means 4 by 6. So it is nothing but what? 1 plus 4 5, 5 plus 5 plus 5 plus 1, 6, 6 plus 4, 6, Piyush Kumar, 6 plus 4, how much it is? 10, 10 by 6, 10 by 6 is nothing but what? What is the answer? 1.666, like that it will be going on giving. This is the calculation part of our variance. So now I hope this is one. You can take your pick also if you want. I'm going to press the enter key so that this calculation will take going off. So if you want, you can take the pick of that, pick of this calculation part. Now I'm going to press enter key. Now I'm going to press enter key. So 10 by 6, you see what is going to be the answer. What is going to be the answer? So coming to the point of it, now I'm going to give you the calculation. Press enter key, press enter key, print off VAR. What is the answer? 1.6666, we got it. Aditya, why ma? Why 0.66 ma? So not 0.66. It is called 1.6661. Are you understanding this? Are you understanding this variance, guys? All of you? Did you understand the calculation? Did you understand this calculation? Okay. So variance is equal to, this is the one I got it, median I got it like this, mean I got it like this, and then output of this I got like this. This is the data what I'm having. This is the data what I'm having. I hope you are understanding me, what I'm trying to call this part. Okay, this is the one. Okay, related to the axis, I want to go for it. Axis wise, this is total mean. I want to go for the next one. Mean, comma, axis is equal to, axis is equal to 0. That is nothing but print of m, which is called, this is the 3 and this is also 3. Now I will apply result is equal to, res is equal to, that is whatever you have, result is equal to, or column variance is equal to variance of np dot variance of comma axis is equal to, I'm saying that 0. You can easily understand 2 minus 3, 1 whole square means 1 only, 4 minus 3 called 1 only, 3 minus 3 is called 0. That is 1 plus 1, that is 2. 2 by 3 is called 1.5. 1.5, no, na? So 1 plus 1, that is called 2 by 3. 2 by 3 answer, 0.6667. Okay. So shift guy, come on, ma, good. Next is called one more, you take it. This is called 3. 1 minus 3, 2 square, that is called 4. 0 and 5 minus 3, that is again called 4. 4 plus 4, 8 by 3. 8 by 3, how much? Yes. So look at the answer. Print of column variance. Column variance is equal to, comma, I will write column variance. So I'm writing, see, this is an answer we are getting. Column variance you are getting. So column variance you are getting. So column variance is equal to, this is the data what we are getting it. Are you able to understand? Fine. So coming, yes, so this is the one which we are going to introduce something like this. Okay. Now let us move to the further discussion here. As we have seen that, this is like a column variance. Let us go for row related kind of thing. Row axis is equal to 1. So mean, you print the mean. I will copy that also. Then you apply the column, this is called row variance. Row variance is equal to, I say, axis is equal to what? 1. You print that, you say here, there I am writing column that is called row variance. Row variance is equal to, I am writing here, row variance. Row variance is equal to, I got the output like this. You can calculate this type of part. This is called 2 minus 0.25. You can calculate in the fractions, it will come 1 minus what will come? 0.25 will come. This is nothing but, I hope it is called what? Row related. This is the first 0.25 from first one, 4 and 3 from second one, and the last one is called 3 and 5 is this one. So where row variance we got it, and then this we got it 1.5 for the first one, and 3.5 for the second one, and the next 4.1 for the last one. I hope you understood this point. Is it clear, my dear students? So I will take it. This is related to standard mean and variance. For this, you got it. So for the axis point of it, we will understand it. Yes, we got it. Now, next point is, this is related to variance kind of things. Fine, guys. This is variance related. And the next is, this is the printing this column variance. Yes, M is equal to, got the data. Then this is the one we got it. Then got this data. Now completion of this. Now I will go for standard deviation. I want to go for last part is called standard deviation. Actually, it's very simple. Even if you go for data science level, if any new concept, if a data science algorithm they are introducing, for example, if any function they introduce, which is a part of NumPy, that time that algorithm related kind of function they will use in the NumPy. So NumPy modules will be NumPy kind of functions will be different for data science level. So you will come across this. These are called essential things. If anything new, you can easily understand how we are using NumPy and all those things you are getting it. And further things will be dead easy for you. So coming to the variance is done. Next I will go for what? Last one is called standard deviation. Standard deviation, I want to go for it. So let us start with the standard deviation here. Now I'm going for standard deviation. Yes, students, look at that. Standard deviation, I want to go for it. What is the standard deviation purpose is? Simple. Standard deviation purpose is that is nothing but applying what? Square root of variance. Anybody knows the formula? The formula for standard deviation, the formula for STD is equal to, SQRT of variance. SQRT of what? Variance. SQRT of what? Variance. So the formula for standard deviation is SQRT of variance. Okay. Then how we go for the examples? Now I'm going to use the examples. Just it is a matter of applying the square root. You see that here you are having variance. Here you are having variance. Square root of this one, you will get it. Square root of this 1.66 square root. I got the column variance square root. We will apply square root of this one and square root of this one. We will apply 1.5 square root, 3.5 square root, and 4 square root. 0.5 square root to 0.5 square root, 1 square root will come. SQRT of variance only. So what is the syntax? What is the syntax 1? Syntax 1 we are going to apply. What is the syntax number 1? Same as this one only. Same as this. As it is, I will take it. So I'm taking this part as usual. Syntax number 1. Variable number. What is this? STD of ndarray object. Internally that formula is applied. Syntax number 2. This is called what? STD. STD. This is called what? STD. Standard deviation for column wise. STD. Standard deviation for what? Row wise. Standard deviation for row wise. This is called the information about this part. Okay. Example part we will see. Example we will cover. Let us go for the examples part. Easy. Nothing is difficult about that. Go for that. Let's take the same example so that it is easy for you to understand it. So let us take NP as numpy, array, as usual, print A only. Then, of course, directly I will apply variance, print that variance. And next, STD, standard deviation. SD is equal to NP dot STD of A. Print SD, standard deviation is equal to comma SD. So you'll be getting the answer is something like this. Okay. The formula for that is supposed to be like that. Next I will apply the another one which I will go for it. Next you see I will go for next part of this is continued like this. See that axis is equal to column variance you are taking, column STD you are taking. When you take column STD, you are writing a column STD. You are taking that's a one. And row STD you take it. Row wise STD. Rows wise standard deviation. This is called one. So print I take standard deviation at column wise. Yes, is equal to that is COL STD. This is the data what we have. Next, standard deviation at row wise. You are getting what is this now? Row STD. So you are getting this type of data. That is earlier is called what? You know, 0.25. 0.25 means this one is coming. Perfect. No doubt in that. 0.5 and this is called what? This is called 1 square root is nothing but 1 only. So you got, this is the information about this part. So coming to the point of it, this is the standard deviation related information. Okay, right, done. This is about the standard deviation, variance, all these things. Is it clear, my dear students? Is it okay? Fine. So coming to the point of it, standard deviation at row wise, standard deviation at column wise, all those things we got it. So this is about complete thing. Yesterday I just sent it to you only few functions. Today it was completed. Now we are using it. Let me take another most important principle which I want to take it. How do you get the data? How do you get the data? That is what I am going to introduce now. So let us start with the another important point which I want to discuss in this class. Select the elements based on some condition from ndarray object. It is also very frequently used thing in our application development. What is that? Select the elements based on some condition from ndarray object. So statistical functions are clear, arithmetic operations are clear. Very frequently, any type of new algorithm comes in data science, that type of related functions also they will provide it. So such functions, if any other module they are present, we can install that module and we can use it. You know how to install that module and how to use it. Module name dot function name, module name dot function name. Axis is equal to 0 means columns, axis is equal to 1 means rows. Okay now. So now I am going to introduce another type of discussion in the class that is called selecting the elements of. I am taking here. Now I am writing here. Selecting the elements of ND array object based on some condition. Selecting the elements of ND array object based on some condition. Very, very important. Let me start discussing this. Okay, right. Let us start discussing about what exactly the meaning of it. Very, very simple. See, I'm having certain elements. See, students, I have certain elements. What is that elements we have? For example, I have the elements called there. Something like, 10 is there. Some number of elements are there. Integer data is there. I want to find out the elements which are only positive. I want to find out the elements which are negative. I want to find out some elements which are even numbers. Some elements are odd numbers. I want to know some type of condition-based elements. I want to retrieve it. I want to retrieve the elements back. How we can get it? That I want to pass it. So let us apply some type of conditions here. Look at that. I will take the example first. I will show you the example so that you can understand perfectly. So import as usual. Let us take this. Need not write every time, but a fresh example. A is equal to np.array of, take some elements, 10, minus 5, 20, 40, minus 3, minus 1, some 75, some elements. This is the list I have. This is the list what I am having. Print A. This is the data what we are having. Yeah. Immediately I want to find out how many elements. I want to retrieve which one. Negative elements I want to retrieve. I want to retrieve the negative elements. How do you retrieve the negative elements? Something like this, you see. Some x is equal to a, simply a less than 0. A less than 0. Negative numbers means what? Less than 0. Am I correct, ma'am? See that condition what I am applying. I am applying the condition on the ndarray object. So what is happening? You see, x is prepared. That x is called a Boolean array. Here you see x is equal to, I am writing here, x is equal to, what is the elements are preparing here? 10. 10 less than 0, it is called false. First entry is called false. Minus 5 less than 0, it is true. Next is called what? 20, that is called false. Condition was not satisfying here, you see, all of them. 40 is called false. Next is called what? 3 is called true. Next, minus 1 true, minus 75 is false. This is called what, Boolean array. This is called a Boolean array. This is called a Boolean array. So Boolean array means what? Which is containing true and false values. Print of x mark, or you print x only, simply you print x. See that carefully. Array, this is also Boolean array we can call. 10, condition is now false. Next, minus 5, true, false, true. What is this is called? Boolean array we can call. Such a Boolean array we will pass to the ndarray object. Result is equal to, you say a, ndarray object you pass it. Of x you say, x. Of x you say. You apply on x. When you say a of x, what is happening? False related elements will not be selected. How it is applied? False, first element, not selected. True, selected, that will kept in res. False, not selected. 40, not selected. -3, it is true, selected, kept into res. -1, true, is selected, kept into res. 75, not selected. How many elements are selected, ma? How many elements are selected? 3 elements are selected. Three elements are selected. Print res or simply print res. Simply print res. See that what is coming? I am selecting the elements based on my requirement from ndarray object. From ndarray object. Did you understand this process? Very, very important process. Is it understandable? Yes. It's very, very important process, my dear students. One should not forget. One should not forget. Okay. This is called one mechanism. This is called one mechanism. So what is this mechanism? Let us start the explanation. First, what are we preparing? What are we preparing? Boolean array we are preparing. Boolean array we are preparing. Pass the Boolean array to whom? ndarray object. Pass the Boolean array to whom? ndarray object. So that we will get the desired result. Did you understand? Did you understand this? Prepare the Boolean array. First prepare the Boolean array. Yes, we prepared it. Pass the Boolean array to the ndarray object. We are getting the result. Let's go to that. I will write some small description. We can select the elements of, we can select the elements of ndarray object based on some condition with the following techniques. We can select the elements of ndarray object based on some condition. That is what Boolean array preparation is useful to us. Based on some condition with the help of the following techniques. With the help of following techniques. With the help of what? Following techniques. What is that now? First one. First technique. Technique number 1 or approach number 1. Approach 1. I am taking approach number 1. What is this approach number 1? I am going to take up. What is that approach number 1? I am giving the things here. Steps. Step number 1. You see? Step number 1. Prepare Boolean array. Prepare Boolean array. Which contains what? True and what? False. True and false combinations. True means condition satisfied. False means what? Condition not satisfied. Combinations, yeah. Combinations. Prepare Boolean array which contains true and false combinations. True and false combinations. It is nothing but an example. I am giving you the example immediately. So I will write the syntax here itself. How do you pass it? Boolean array. Variable name is equal to some variable name, or simply I will write variable name. Why such a big variable name? Variable name is equal to ndarray object with condition. With condition. Keep in mind that with condition. ndarray object with condition. With what condition? ndarray object with condition. Yes. Variable name is equal to ndarray object with condition. Are you able to follow me? Yes. Next is called step number 2. Prepare Boolean array which contains true or false combinations. Variable name is equal to ndarray object with condition. Example, if you want, I can get you immediately there itself. What is this now? Take that np array and I will take this. This is the one. First point, it is done. Here itself, I can pass example itself. Example itself. Yes, here I will take it. Here I am taking. Here I am taking. Okay, right. This is the array which is printed. Boolean array printed. This is called condition. ndarray object with the condition mark. Boolean array object with the condition. This is ndarray object with the condition. Yes, so print that x. Here that x is called what? Boolean array. Here x is called what array? Boolean array. And x is called Boolean array. Boolean array. Boolean array. X is called a Boolean array. Fine. Okay. After that, this is called one step. First step example only. This is called first step example only. Step number 2, I am talking about it. Step number 2, I am talking about it. Step number 2. Step number 2, I am talking about it. So in step number 2, what we are going to do? Step number 2, what we did here, pass that Boolean array to whom? ndarray object. Pass that Boolean array to ndarray object. Let us go to that. Step number 2, I am saying that. I am going to that. So step number 2, pass. I'll say, pass the Boolean array object. Boolean array object to whom? ndarray object. ndarray object. ndarray object. How do you pass that? How do you pass that? I say syntax. What is the syntax here? I say syntax. What is the syntax here? What is the syntax here? ndarray of Boolean array. Boolean array. Here, if you want, I can write it. Here, variable name. Here, variable name. Here, otherwise you don't know Boolean variable. Here, variable name is called Boolean array. Is called Boolean array. Is called what array? Boolean array. Yes, Boolean array passed. So that what we will get it here, you can write a variable name. So here, variable name contains result. Here, variable name contains result. So our example is going to be what? This I will write the result. What is that result is going to be like this. This I will take it. So this will give you the approach of, yeah, this is gone. I'll pass it. Take this part. Here I am writing. Here I am writing. X result is printed here, which is nothing but obtaining. So this is nothing but obtaining. Which one? Even negative numbers. Obtaining which numbers? Negative numbers from ndarray object. ndarray object. Obtaining negative numbers from ndarray object. Obtaining negative numbers from ndarray object. Yes. Pass the Boolean array object to the ndarray object. So variable name is equal to ndarray object of Boolean array. So I passed it. So coming to the point of it, done. So I hope that it is clear for you. Is it understandable, ma? Is it understandable, guys? This is called first technique. This is called the first technique. Come on, everybody. Today is slowly you are responding. Slowly you are responding. Are you able to get my points? Are you able to get my points, guys? Yes. Very good. Next, this is called approach number 1. I want to go for approach number 2. What is that approach number 2? Very, very simple. You can easily understand also. Not a difficult at all. Not a difficult at all. So how easy to understand those things? You see, here I'm going to write it. Approach number 2. Approach number 2 I'm taking. What is that approach number 2? Simply step number 1. Step number 1. Look at that. Look at that. I will take it as what? Directly I will pass what? Approach number 2. Create the Boolean array condition. You see, only one step I will take it. Only one step I will take it. Look at that. Only one step. Step number 1. Step number 1. Pass the Boolean array. Pass the Boolean array. Pass the ND array. ND array. ND array. With the condition. With the condition. With the condition. See ma. Pass. I will write like this. ND array with the condition. To the object of ND array directly. Actually, see this one you see. Observe it. Shortcut you learn it. ND array. Boolean array means what I can write it. Boolean array means I can write it. This one only, na? Yes or no? Yes. Simple. I can say condition is pass the ND array with the condition to the object of ND array object. I can take it. This one only. This one only I can pass it. ND array with the condition. I can pass this part. Here only. Directly I will use it. Directly I will use it. ND array with the condition. ND array with the condition. Here variable name contains the result according to us. Come on. Example you take directly. Step number only one step. Go there. Say numpy. Yes, A. So directly what is my array? Here result is equal to A less than what? 0. A less than 0. See all of you. Print res. Print res. Print res. See the result? Same result. Same to same. Same to same. Am I correct? Am I correct? Yes. Simple thing. Very, very easy thing. This is what we got it. This is what we got it. Directly example is given. So I got it. Result. So I got it. This result. Array. A of A less than 0. That is nothing but containing ND array with the condition. So passing to an object of it. Here ND array. Here the comment I can write it. This is a main statement mark. Here this is a main statement. ND array with object. Passing to the object of ND array object. So the result is something like this. Okay. Now let me go for some small example here. Take the same example. Take another example here. What is my example here? What is my, okay, take it same thing, right? Now I'm asking you, get the positive values. Get the positive values. Two approaches. X is equal to, first prepare the Boolean thing. I will take a greater than what? 1 minute more. I will take 1 0 also. I will take 1 0 also. 0 also I will add it. Okay, na? 0 also I will add it. 0 also I will add it. Now, some Boolean array BA is equal to A greater than 0. Two things I am passing. So BA is Boolean array is printed. 10 is true, true, false, false, true, etc. Last is also called false. Why? Because you have written greater than 0. 0 greater than 0, false. Right? And past that, RES is equal to, that is called positive elements. Positive elements is equal to POS elements. POS elements is equal to what I am writing? A of BA. A of BA. What is that? You see, positive elements. POS ELE. I will get the positive elements. 10 is a positive, 20 is a positive, 40 is a positive, 75 is the positive. These are the positive elements. Or instead of that, you can say simply, I can say like this I am writing, or comment of course I am writing. Dear students, don't worry. Comments I am writing, that will not consider at all. You know already I wrote commenting symbol. I can directly write it. POS elements is equal to, tell me how do you write it? A of A greater than 0. A of A greater than 0. Am I clear? So print of what? Positive elements. getting the same output. So simple, very, very simple. Yes, very, very simple. Easy. This is called getting the positive elements. Boolean array. With a Boolean array, you are getting. With the condition, you are getting. Positive elements, you are getting. Retrieving positive elements with both the approaches. So this obtain question I am writing here. Question obtain which elements? Positive elements. Positive elements. Positive elements. We are getting positive elements. I hope you are understanding positive elements from ND array object. ND array object. Okay, right. Because these are very, very simple things. Done. And the last and final, to get you more confidence, directly you go to the approach. I will take one small thing. Import of this. Yes, I will take some elements here. I'll take some elements here. Some 21, 24, 31, 46, 45, 27, 39, like this. I want to, okay, close it, done. A is equal to, print the even numbers and odd numbers directly. Odd numbers, ON is equal to directly A percent of 2 not equal to 0, not equal to 0. Odd numbers, this is. Even numbers is equal to, how simple you see, even numbers is equal to A percent of 2 is equal to 0, Print, what is this now? Odd numbers is equal to comma, ON, I got it, odd numbers. Even numbers is equal to what? EN. So this is a even numbers, we got it. Are you getting, students? So getting more clear? Yes. Done. This is one kind of short example. So you understand this array of elements. So obtained even numbers, obtained odd numbers, then done. The question itself is clear for you. Obtaining even numbers and odd numbers. Question is obtain even numbers and odd numbers separately, because it is the most useful thing for you. Obtain even elements, even and odd numbers, even numbers from ND array object. Obtain even and odd numbers from where? From ND array object. From there, you need to get the data. This is a way how you can retrieve the data from ND array object. Is it clear? Is it understandable? Yes, sir. Simple, sir. Next I want to go for, of course, very, very simple. There is one, yes, ma'am. Yes, Aditya. Try to work in such a way that it should work properly. A percentage to not equal to 1. You work it out. So remainder is not 0. With the percentage to, you take it as not equal to 0, odd numbers. Equal to 0, you take it as even numbers. Not equal to 1, you test it and then see that. Okay. Now, there is one more thing is there. Of course, if it is useful, you use it. If anywhere else, if you come across, there is one term is coming there is one term is there in our NumPy. Broadcasting concept is there. Broadcasting. What is the concept called? Broadcasting. Right. Yesterday's class, when we are performing, this is called what, ma? Retrieving the data, selecting the elements of ND array object. Selecting the elements of ND array object based on some condition. Let me save it. Go to your place of this one. Save this data. And previously also statistical function, anyhow it is there. Now yesterday while we are performing some operation, let us watch this now. Let us watch this. Of course, this is a very simple. Say as usual, say here, A is equal to NP dot array of C 1020, comma 30, 40, 30, 40, 30, comma 40, 30, comma 40, 1020, comma 30, 40. This is my data. This is my what happens, ma? What is missing? Yeah, okay. It is missing. Inner list it is missing, ma. Inner list it is missing. Okay, done. Okay, anyhow, once try to see. Okay, done. So this is A, you print it. B also you print it once. B also you print it. B also you print it. That is called 1, 2, and then 3, and then 4. This is my data. B you print it. This is the data. This is the data. So A value and then B value we are getting. 10, 20, 30, 40. B value 1, 2, 3, 4. Can I do addition here? Can I do addition here? Yes. So we already done A plus B. Directly you can say A plus B. We got it. We already did star B also, element wise. Yes, ma, you can do that also. We already did yesterday. A dot NP dot add of A comma B. Also we did. This also same to same. Like that, we did our operations. Now I am asking one question today. C is equal to, of course, I am saying that 100 comma 200 I am writing. 100 C is equal to NP dot array of something like 20 comma 40. I am writing 20 comma 40. Or if you feel, so why that is 15 comma 25. I am writing 15 comma 25. Some unique name I am giving. You print C. Now I want to say print of A plus C. A plus C, valid or invalid? All of you say. Come on, everybody. Very good. Everybody feeling that it is invalid. But in Python, it is in NumPy, they made it as valid. They made us valid. Okay. Do you know what is happening? Actually, yesterday's class we did some example also. If you remember me, I had some small explanation I gave you, arithmetic operation. If you remember, yesterday only we got that error. I posted that error also. You just see 1 minute. 1 minute I just want to show you. You see, subtract function. See, this function is used for subtracting two matrices, provided order of the matrix must be similar to the order of second matrix. Otherwise, we get an error. What is that? Operands could not be broadcast together. Shapes, different shapes are there. That time it is going to be. That time it is going to be invalid. Yesterday's class we said this. In today's class, how it is valid? You know, dear students, when you are taking A plus C, when you are taking A, this is 1020. 1020 is the first row, this is the first row added. Do you know? Actually, this is called one single dimensional array. This is called a two-dimensional array. Do you know what is happening? This also will be converted into two-dimensional array. It will take the same value again. Actually, do you know C is equal to, actually it is supposed, it is taking internally as 1525. 1525. Again it is taking 1525. 1525. That is nothing but 1020 is adding with that, and this also will be adding with that. Nothing is there, mind this. 1020 adding with the 1525. 3040 also adding with the 1525. Are you able to understand? Is it understandable? Simple. Nothing is there. No concept is available there. Nothing is there. Nothing to worry. See the answer now. See the answer now. What is coming? 10 plus 15, 25. 20 plus 25, 45. 30 plus 15, 45. 40 plus what? 25. It is called 65. Is it understandable? Is it okay? Yes, students. Yes. Simple. NP dot add of AB, add of AC, same. So what is happening there? What is happening actually? The same thing happening with the same kind of thing once again. This is called as broadcasting. They are saying broadcasting means what? They are broadcasting the same entry once again as a new entry, so that every element of this matrix, two entries are there, two entries will be done. Two entries will be done. I hope you are understanding what I am talking. Is it okay? Is it clear, students? And moreover, columns must be same, students. Columns must be same. And this is may be required, may not be required. Especially speaking, in our matrix point of view, it is called invalid. Even if it is coming, okay, they gave some facility for it. Okay, they gave some facility for it. They gave some facility for it. Mr. Sumit, Seema, A minus C also you see. A minus C also you see. All the operations are possible. Need not have any such type of doubts. So for that, I just prepared one small information for you. Are you understanding this? Actually, this may be required, may not be required. Actually, such a type of things you take it as very lightweight. They are also saying in the documentation of NumPy, it may be required, may not be required. Yesterday, error was irrelevant outputs I took it. Irrelevant outputs. Irrelevant outputs. So see, D is equal to UC. I am taking NP dot array. NP dot array. You take it. Yesterday I was taken like this. If you remember me, yesterday I took like this. 10, 20, 30, 10, 20, 30, comma what? 30, 40, 50. 30, 40, 50. 30, 40, 50. This I was taken like this. This I was taken like this. This I was taken like this. You see D. Now you try to say, N A plus D you write it. A plus D you write it. See that error. Sumit, did you understand? Operands could not be broadcast together. It is a 2 and 3, and next is called a 2 and 3 different shapes. So it cannot. It is actually known thing only. Simple ma. This is nothing but each value of our matrix is added with it. Nothing is there. And I don't think much serious about this part of the programming. Just since it is there, I just want to cover it. Yes, just I just prepared a small document. Instead of typing, I just prepared in my free timing. So shall I show you that? Shall I show you that, man? Yes. Look at that once. I just prepared a small documentation. I prepared example also. NumPy broadcasting. The term broadcasting refers, the word I am writing, the term broadcasting refers to the ability of NumPy to treat arrays of different shapes during what? Arithmetic operations. What is our operation earlier? What is our operation? It is a 2 by 2 matrix, and one more is one dimensional, one dim, and another one is different dim, two dimensional and one dimensional, different shapes. Arithmetic operations on arrays are usually done on corresponding elements. First element, 0th element, second to second, third to third. Am I correct? If two arrays exactly same shape, then these operations are smoothly performed. Am I correct? Is this paragraph is understandable, ma? Is this paragraph is understandable? Yes, guys? Fine. Yes, I want to get the conclusion from you. Broadcasting is an ability of NumPy to treat arrays of different shapes during arithmetic operations. In arithmetic operations, different shapes are there. I want to consider them. Arithmetic operations are usually done on corresponding element. Element to element it is done. If two arrays are exactly same, then the operations will be conducted smoothly, performed smoothly. Example is what? NumPy. It is called 1D. This is called one only, smoothly performing. 1 into 10, 10, 2 into 20, 20, 40, 3 into 30, 90, 4 into 40, 160. Now, if the dimensions of two arrays are dissimilar, which we have seen now, A is called what here? A is called what here? This one. B is called the same. 2 by 2, happily A plus B, okay. Add also okay. But this is called what? Different dimension. That is what my word is. If dimensions of two arrays are dissimilar, element to element operations are not possible. Why? First row matchings. For second row of first matrix, it is not having any row in the second matrix. However, operations on arrays of non-similar shapes is still possible in NumPy. Even though they are different, non-similar shapes is still possible in NumPy because of the broadcasting capability. Dissimilar type, element to elements are not possible. Not meaning is what? This 1020, here you wrote A plus C. What is the value of A? What is the value of A? 1020. It is added with that. And for 3040, there was no row now. Actually, it was not possible in mathematics. But in NumPy, there is a capability called broadcasting. The smaller array is broadcasted to the size of larger array so that they have compatible shapes. That is what I told you. This is called 1525. This is called 1525. 1525. Actual size is 1525. The smaller size array is broadcasted to the equal to the size of what? Bigger array. So 1525. This is going to be 10 is going to be with the first, 10 is going to be with this, 10 is going to be with this, 20 is going to be with this, and 30 is going to be with this because it is made it equal to the bigger size. 25 is done. This is what I written here. The smaller array is broadcasted to the size of larger array so that they have compatible shapes. What, students, is it okay? Students, are you okay? Everybody. Simple. Broadcasting means what? Smaller size is broadcasted to that. You may ask a question, sir, why you are getting this is different shapes? This is totally different. 3 by, it is the 3 things are there. This is 2 things are there. It is having only 2 things. 2 things. So what will be the next one? It is a question mark. Not similar thing, not different thing. So here we are getting, see, This is going to, again, I am saying the same thing, because don't think that this is a very simple. 1525 is one entry. This is made it equal to what? This is having two entries here. First A is containing two entries. This entry is matching with this entry. And another entry is nothing but it can add with, I can say 30 with 15 and 40 with 25. Rather than doing the first row, second row, the same entry will be taken. 1525, 1525 will be taken again. Are you getting me? Because I wrote a very clear description here. The smaller array is broadcast to the size of what? Larger array, so that they have compatible size. So here 10, 20, 30, 40, 50, 60, print A, 256. How many rows, how many here, how many columns are there? First of all, 2 columns are there. Here how many columns are there? For example, think first column, second column, third column. How many rows are there? 2 rows are there. How many rows will be taken in smaller one? Extra one more row will be taken. What is that row? Same row. Same row. Print B. Print B. This is the B. C is also going to contain what? 2-dimensional only. It is going to be prepared 2-dimensional. With 256 is the next entry. No, mono. You think very carefully. This 256 will be taken as a 256 only as an entry. A dot shape. A dot shape. This is a shape we are getting. This is a shape you are getting. And B dot shape. What are you getting here? 3 columns you see. Columns you see. Automatically that also will be converted into same number of elements also will be taken. Simple words. If you are not able to get it, every element of this will be multiplied or added with these elements only. In simple word, I can say. Instead of breaking our heads not to get it, this I am saying that here 2 rows are there. Here 1 row is there. For matching with the second row, write the same element 256 once again. For that, internally our numpy is providing like that only. Mono, is it okay, ma? So here instead of 256, instead of just 256, what is taken here? They are taking it as internally the numpy is considering it as 256 once again. 256 once again. This is a smaller array. Smaller array is compatible with the bigger array by having the same shape. So 256 is added to 256. Corresponding elements are added. Corresponding elements are performing the operation. Depends on the operation you are using it. Other than that, nothing is there in this. Nothing is there in this. If columns are different, you are getting that error now. Broadcasting error we are getting now. Here I shown you already, right? Here I shown you already, right? Here how many rows are there, ma? 2 rows. Here how many columns are there? Extra columns are there. Here getting error na? Getting error. Right. So already this is there. And don't think too much about it. It is very, very simple. So done this answer. Done this answer. This we got the output. This we got the output here. Right. And then A adding of this. Everything is done. Everything is done. Okay. It's very simple. Not at all difficult. Don't think much about it. Very, very easy. And this also multiply also. We are having this. Right. So done. So coming to this point here. Right. A minus B also you can do. Any type of operations you can do it. So this type of thing mathematically not possible. In NumPy, this capability is providing. Whenever you need, you consider it. Otherwise, you are also getting, here it is different columns are there, you are getting errors. Hassan Ali, same. Same. Yes. It is like our childhood days. Number of columns in the first matrix must be similar to the number of columns in the second matrix, so that will be adjusted to the matching with the first array. So this yearly I mentioned very clearly. In this concept only I mentioned very clearly. If the dimensions of 2 arrays are dissimilar, element to element operations are not possible. However, operations on arrays of non-similar types is still possible in NumPy because of the broadcasting capability. The smaller array is broadcasted to, broadcast means sending, broadcasting means it is giving its capability as a size of larger array, broadcasted to the size of larger array so that they have compatibility. Here having only one. Here you are having only one. It is placed once again the same next entry so that 2 rows are there. Here also 2 rows are there. 3 columns are there. Here also 3 columns are there. That is an internal capability what NumPy is doing. If we question to the NumPy, I don't want 256 as a next entry, then there is no answer with the NumPy. Is there any answer with the NumPy, ma? Is there any answer with the NumPy? No. So they are considering this. They named as broadcasting. They named as broadcasting. Suppose I don't need. Why should I take 256 again as a next to 256? There is no answer. Even in Stack Overflow, there is one website. It is a common open forum where the people can discuss. So it is not a fair approach where we can have the broadcasting is going to be a universal concept we can use everywhere else. So if I don't want 256 again as 256, there is no meaning of it. Right or not? So see, these are the, for example, you take even that was example even in the Stack Overflow website once it is done. These are the infected people. This is the total population in India, for example, represented in the matrix format. Represented in the matrix format. Population in India. Population in India. State-wise population. State of population. State of population. Like that they mentioned it. And these are the infected people medicines. For the first thing is they are going to give you infected people in the states, and other states are not containing any non-infected people. These are the tablets for the infected people, and these people need not to take this. That time, what is the need of the broadcasting? Broadcasting is not necessary there. So fine. These are the things requiring this. Other next element, I don't want to have the operation with the same elements in the next. So that time there is no use of such. Are you able to understand, guys? Is it understandable or not? Fine. So actually, when we go for thinking about it, it is not necessary. Okay. Then this is about broadcasting concept. So you know how to take indexing, how to take indexing, how to take indexing and all those things. You know, na? You know how to take indexing and all those things or not? Yes. So how do you take indexing here? If I take it, this is a NP and a D I'm taking. How do you take this index, ma? This is the, what is the index of it? Come on, D of 0th row, comma 1. 0th row, comma 1. What is an element is coming? What is an element is coming? Like this. We can perform. So we can retrieve the element from any of the index. We can perform the element from any of the index. Are you able to get it? Simple. Simple. We can get the index of any of the elements. So that is already indexing and slicing. We are aware of it. So anything, this is operations, how to create an object, how to do the operations on it. This is what we used to talk about in this area. So did you understand this broadcasting, ma? Did you understand this broadcasting rule? Yes, not a difficult at all. Not a difficult at all. Right. So coming to the picture of it, statistical operations are most useful. Arithmetic operations are most useful. How to select the elements from NumPy array, that is also most useful. Most useful. Right. Now you see, I want to retrieve from the elements like. So how we are retrieving the elements? We are just printing these elements here. Right? Yes, ma, Sumit. Yeah, exactly. We go for Django also. There is no doubt in that. Yeah. So with this, this scenario will be extended to the data science level also. So when you go to the decision tree, when you go for the Keros, when you go for the AI, when you go for the ML, that kind of algorithms related functions will come. So that functions once again will be available in the NumPy level. Are you following me? Like you are learning Python. Python we are using in data science level. Python we are using in Django level. Coding we are perfect. So when Python level, when we are using in ML some algorithm is coming, that algorithm related function is available in NumPy. Whenever that algorithm is there in NumPy, that you can happily use it. So because already you know NumPy how to install the module, how to call the function and all those things. Okay, students, did you understand the scope and wide range of this Python which is available? Right. So, and this is a trending according to the today's survey. Most of the United Kingdom and Canada in different places, Python is using 37% popularity is increasing day by day. Okay, and the Java percentage is coming down. It gone to the 19% as on today. It seems it is a survey what they are teaching. So yes, ma, Tausif, I am going to teach the time complexity in the multi-threading. I already told you. I think so. You asked me once. I told you that. In multi-threading, I am going to teach you that. In multi-threading, I am going to teach you the how to measure the execution time of our program. Okay, students? Fine. Next, this data, this NumPy data, this NumPy module, at this point of time, this is what we used to teach. And in the next continuation part of it, we will introduce continuation part of it. Pandas I want to introduce. Pandas I want to introduce it. Are you understanding? So now it is almost 7:30. It comes to. Shall we introduce the pandas in tomorrow's session? Today is almost. If I introduce pandas now, it may not be completing. Tomorrow class I will introduce pandas. So don't miss it. Important session. Pandas I will introduce in tomorrow class. So up to here I will upload it. Right. So, yes. So tomorrow class, I will introduce what? What is our tomorrow's class, ma? All of you tell me. What is our tomorrow's class? Pandas. So that is also very, very easy for you. How to install pandas? How to install pandas? Pip install pandas. Pip install pandas. Good. That's it. Anything else is coming in the near future. Pip install pandas. Pip cx underscore. Pip install NumPy. Like that we can install and we can make use of that. Very, very simple. Nothing is difficult. Okay. So can we stop it now? Come on, students. Can we stop it? Yes. So I will stop the session and I will upload this information. And tomorrow we will start the pandas concept. Okay. Thank you. Good day. All the best.